All right, guys, we are moving on to 8-7. So 8-7 is factoring perfect square trinomials or difference of squares. Okay, so perfect square trinomials or difference of squares. So it says the diagram shows two adjacent squares and their areas. In terms of x, how much taller is the left square than the right square? Explain your reasoning. All right, so pause the video, see if you can tackle this one and figure out how much taller one is than the other. All right, assuming that you've paused it, let's see what we have to do here. So in order to figure out which one's taller, we need the heights of each one. Okay, so if I want to figure out the height of each one, I need to figure out the dimensions. Okay, well, the square is easy. This is just going to be 5 times 5. Okay, and then, but this one, I have to factor this one. All right, so I got to find the dimensions. So I'm going to write x squared plus 14x plus 49. And then I want to factor this into the dimensions. I know it's a square, so they're going to be the same. So what I need to do is I can use the x method. Okay, we're going to learn a little trick later on to kind of figure out a faster way to do perfect squares. But you really don't need the trick. You can always just use the x method for this. So what multiplies to 49 and adds to 14? Well, it's going to be 7 and 7. So this is going to be x plus 7 times x plus 7. All right, so this is x plus 7. So another way to write this, by the way, before we move on here, is I can write this as x plus 7 squared. So all of these three things, they're all equivalent. Okay, so that'll be helpful for you to know that. So now the next step here is I just have to figure out the difference. So I have x plus 7 minus 5. So this is the yellow square, and this is the kind of light greenish lime colored square there. So x plus 7 minus 5 is just going to be x plus 2. So the answer to that is x plus 2. All right, so we got kind of two parts of the notes. First one is to factor perfect square trinomials. And then day 2, we're going to do difference of squares. Okay, so we got day 1, perfect square trinomials. Day 2, 8-7, difference of squares. So factoring a perfect square trinomial. So what is the difference of x squared minus 12x plus 36? Or what is the factored form of it? Well, we have the area of this square. It's x squared minus 12x plus 36. And we want to figure out the dimensions. All right, the length and the width. So I'm just going to use the x method here. What multiplies to 36 and adds to negative 12? Well, that's going to be negative 6 and negative 6. So this is going to be equal to x minus 6 times x minus 6. Or you could do x minus 6 squared. Excuse me. All right. Try these two, the got it problem, A and B. So pause the video, try these two. All right, again, assuming that you paused it, let's try to figure out what these factor into. They're both squares, so I know that the dimensions are going to be the same, the length and the width. So what multiplies to 9 and adds to 6? It's going to be 3 and 3. So this is going to factor into x plus 3 squared, or x plus 3 times x plus 3. Over here, this is going to be what multiplies to 49 and adds to negative 14. If it adds to a negative, well, I know these both have to be negative because my last term, my c value is positive, my b value is negative, so they have to be two negatives. So this is going to be x minus 7 squared. So that's my factored form. And again, x minus 7 squared is equal to x minus 7 times x minus 7. All right, moving on here. Actually, we're going to go into difference of squares today. But let's look at this one, problem 2. So it says digital images are composed of thousands of tiny pixels. Okay, TV and computer, iPad, thousands of tiny pixels, as shown below. Suppose the area of a pixel is 4x squared plus 20x plus 25. What is the length of one side of the pixel? So now I know that the area is 4x squared plus 20x plus 25. Well, my a value, I can write it up here. My a value is 4, my b value is 20, and my c value is 25. Well, I know that I could use the x method here, but since my a value is not 1 anymore, I have to draw this horizontal line. And I'm going to do 4 times 25, a times c, if you remember from 8-6 notes. So we're just building on that. This is going to be 100. 4 times 25 is 100. B still stays down here. 4x is here. 4x is here. And this is going to be 10 times 10 is 100. 10 plus 10 is 20. And then both of these are going to reduce. So I can reduce this into 2x plus 5. Okay, so what is the length of one side? Well, this factors into 2x plus 5 squared, but the answer to the question, what's the length of one side of the pixel? Well, it's just going to be 2x plus 5. All right, well, let's move on into, I think we'll do